never get to where I need to go. There I am. Okay.
Kathleen, did you get any snow?
Hang on just a second. What?
I said, did you get any snow?
Oh my gosh, no. When?
Oh, now, but you didn't. Okay.
Like recently?
Huh?
Like recent?
Yeah.
No, we hardly ever get snow.
Oh, that's a good
Not
thing.
very much. Yeah, it is, but sometimes it's fun to get some snow. But
Sometimes.
for
All right.
Christmas.
Yeah, for Christmas, definitely. Who's reading?
It's lesson 21, right?
Lesson 20.
Yeah.
Okay, I was going to open 22. Okay.
Do you guys want me to read? Can you all hear me, or is anybody echoing?
There's no echo today.
Yeah, that's great.
Step A echoing? No.
Nope.
I think you sound pretty good. Some people sometimes it still kind of cuts out, but
Yeah.
do you want me to read? I'll read.
Okay.
Okay. So the first two are on your own. And then, are you guys all there?
Almost.
For number 3? Okay.
Okay, you can go. Sorry, I'm all caught up.
No, okay, question 3. So the correlation coefficient is used to quantify, number 1, the direction and strength of the nonlinear relationship. 2, the strength and reliability of the linear relationship. 3, the direction and strength of the linear relationship. Or 4, the direction and duration of the nonlinear relationship.
Number 3.
Number 3. I agree. Okay. Question 4. If the correlation coefficient is negative, when one variable increases, the other variable tends to decrease. The other variable is negative, the other variable is unpredictable, or the other variable tends to increase.
It's the first one.
Yeah, decrease it.
That's okay.
Yeah, I agree. Okay. Question 5. The effect of outliers on the correlation coefficient is not significant. True or false?
False.
False. I agree. Everybody agree?
Yes, ma'am.
Yeah?
Yes.
Okay. For the next 2 questions, take the Old Faithful thing, data file, and compute the correlation coefficient of duration and weight. Okay, so we have to input the correlation coefficient.
It's so long.
So we input this into
The linear regression.
that new. Yes, okay. And I did it, but this kind of confused me. Some of these, but
Yeah.
Yeah.
So what are we looking for? What are we looking for? We are looking for the correlation coefficient.
Which is R times SX times SY.
Can't we just find it in the little thing?
I don't think so.
No, you have to put those things into the spreadsheet.
But it's okay. It's an easy equation, this one.
Yeah. It gives you
So you
R, X, Y, and gives you SY. And then you just have to compute it yourself.
Oh, so it's not in our little Excel thing?
No. Not the answer, but
Well, I want to find it in here.
I know. But this one's really easy. The coefficient, it's just R times
Yes.
times SX, the standard deviation X, times the standard deviation Y. That one's really easy.
Okay, so R times,
SX times
okay.
SY.
So are those the ones that are given in the
Mhm.
Excel?
Yep.
Okay, okay. I got it. Hang on. You guys are just too smart.
It's because I reviewed all this in the past like 2 hours, so
Oh, okay then.
On it.
it's just very fresh, and I had no time to do it the past couple times.
13.595. Okay. So what'd you get?
13.
What'd you guys get? I'm not going first.
13.976.
Yep.
13.9.
That's what I got, but it's almost the same as this covariance that's listed in here in Excel.
So where are you seeing,
Do you
Catherine?
see that?
The
Huh?
covariance or where in the Excel?
What are you asking?
Hey, where do you find the what is the correlation coefficient in the Excel?
That's what I was asking, and they said we had to figure it out.
Oh, okay.
But if you look under the standard deviations, it says
Mhm.
covariance and it's 13.977. And wasn't there something that said that you were supposed to use the Excel instead of doing it by hand?
Was that on the video?
I can't remember. It might have been.
I don't know.
It might have been.
That I read something that we should use the Excel because it's gonna by hand. It's gonna be like different numbers, something like that.
I know, and I don't know if that must have been on the video. Because I can't.
Watching it real quick. Just to see.
Oh, okay.
I'm gonna get my calculator. Okay,
Okay.
I forgot it. Okay.
So the correlation coefficient. It says it's always between -1 and 1. Huh. That's weird. Where's my thing? There it is. Well, then that wouldn't be right because it right here on the book, in the book,
Uh-huh.
it says the correlation coefficient is always between -1 and 1.
Oh.
That's R. Kathleen, R.
Oh, isn't that what it's asking in the question?
Oh.
Yeah. So it's 0.901.
Mhm.
Okay, so the correlation coefficient is R. And so it's 0.901. Okay.
Yeah.
Okay. 0.901. Wait.
Whew.
Okay. So did we all get that right?
Yes.
Yeah.
So what is the direction and strength between weight and duration?
I would say
Let's
it looks
see.
a little like it's linear, kind of linear in that it's kind of going up this way, the right,
Mhm.
and they're all kind of together. They're not really scattered, so I'd say it's positive.
So what are the choices? Negative and strong, negative and weak, positive and strong, or positive and weak?
I would say positive and strong. Would you guys agree or disagree?
Agree.
I think so. I think that's
Yeah.
right. Yeah.
You guys, sorry, really quick. For question 6, are we still sticking with 13.976?
No, it's 0.901 because it's the correlation coefficient, not the covariance.
Oh, okay. Sorry about that.
That's okay.
Thank you.
Yeah.
Okay. Okay, so are we good with that then? 8? We're good? We're on to 8?
So they said
Yeah.
it was weak when it was what, like 0?
Oh, yeah.
Let me just see. It's always between.
But I can't remember what numbers we're looking at. But I remember that. Let me look. Maybe it's in my, let's see.
Oh, well, yes, it says if there is a strong positive association, the correlation coefficient will be close to 1. And yeah, it's close to 1, right?
Yeah, okay. That makes sense. Yeah,
Okay, yeah.
okay. That sounds good.
Mm-hmm.
Thank you for looking
So,
up.
Yeah.
so question 8 says, match the scatter plot with the correlation coefficient. Okay, this could be fun.
So the 0.95 is number 2. The
How do you
negative.
know that?
So when it's like the straight line, so number 1 is 1 because it's a perfect
Because it's
straight
completely
line in a positive
straight.
Okay.
direction.
Right.
So
Okay.
number 2 is kind of getting more scattered from the straight line. So number 2 is the 0.95.
Mm-hmm.
Oh, wait, I'm doing this backwards. Wait a second. So 2. Okay, I'm doing this completely backwards. Okay, so wait a minute. So 1 is the first one.
No,
I gotcha. Okay.
so the
Okay.
order that it should go is 2, 5, 1, 6, 3, 4.
You're so smart.
You're fast.
Yes, you are fast. How did you get all of that?
I watched
Okay.
those videos.
Well, I did too, but you're fast.
So
Okay.
is this 2? Did you say 2, 5?
Then 5, then 1, then 6, 3, and 4.
6. Mm-hmm.
1, 2, 3, 4. There's 6 of them. Did you do all 6?
Yep. So
Crystal?
yep. So it goes 2, 5.
Okay, wait a minute. So which one is 0?
0 is 3 because it is all scattered across the board.
Okay, so my first one says R equals 0. So that's 3.
Oh, then yours is different.
Are we different?
Yeah, they might.
Oh,
Okay, so
we're different?
I'll tell you this then. 0.95
0.95, yes.
Hmm.
Is 2.
is the one that's kind of scattered up to a positive way. It's not completely aligned, but it's not all scattered, if that makes sense.
Right.
Yeah.
Yours
So
might
that-
be different. So I'm not going to say number 2 because I don't know if your number 2 is the same as my number 2.
But that
Then-
is B. That is B.
Yes, that's
B
what I have.
is 0.95. Okay, yes.
Then I have negative 0.95. That's pointing down to the bottom of the right, if that makes sense.
So that would be E.
I have it as number 5. Yes, so E.
Yes, that's right. Okay.
1 is a perfect line going towards the top right.
So that's A.
Have that as A, that being 1.
Yes.
Then negative 1
Negative.
I have as 4, D,
Yes.
down to the bottom right. And then
And then
0
this-
is C or 3, where it's just kind of scattered along the page.
So negative 6 is
And negative 6 I have as 6 because
the F.
it's
Yeah.
brought
Okay.
down to the bottom right.
Perfect.
Yes, okay. That makes sense. You were just so fast at figuring that out.
Fast.
I know.
You just zoomed through it. Okay.
Sorry, though, I didn't realize that they could all be different.
I know. So, okay, is everybody good with that?
Mm-hmm.
Yeah.
Okay. So now we have to take the math self-efficacy data file.
Yes.
So I got to open that.
Let's hope it's not as long.
Holy cow. This other one is super long. I'm trying to.
Why?
So are we only grabbing the score and the confidence rating mean, correct?
Oh, shoot.
We're not doing anything.
I don't know.
Hang on. I'm having issues.
Yeah, just the number.
I'm just copying and pasting them. Sorry.
Oh, my goodness sakes. Oh. Okay. So this one just has one. Oh, no. Never mind.
No, it has the two. I was a little confused too.
I got it. Hang on. Jeez. I don't know about you guys, but I am tired
Mm-hmm.
today. Okay, hold on. I'm getting it. Well, this one's long too. Okay. Copy. Okay. Now, clear. Oh, you dumb thing. Clear. All right, guys. I'm almost there. Okay. I'm here. Okay. What are we looking for? Okay. Input the correlation coefficient. So that's just like the first one we did, right?
Yeah.
0.728. Yeah?
Yes.
What? 0.7, did you say?
Mm-hmm.
2.8.
Okay, so I got it wrong. Okay.
Well, maybe we got it wrong, Raquel.
Raquel, do you have I guess the column starting with 50 and X?
50 and X. Yes. In the explanatory variable? Yeah.
Yeah.
Mhm.
And 4.34, that column starting in Y.
Yes.
Okay. Mackenzie, did you get 728?
Yeah, I did.
Yeah, I'm the one it's wrong because I got negative 0.904
Uh-oh.
for the R. We're looking for the R, right?
Yeah.
Yeah.
Hmm.
How'd you get that?
I don't know.
Did you delete all of the previous listing?
No.
Oh, that's why.
Make sure you delete all of that stuff before you add your new ones.
Does it like
If your new data is shorter than the old data, it'll keep the ending of the old data.
right?
Right. Yeah. So did you get? Let me just clear it real quick. Okay, for sorry.
It's okay. You guys are always waiting on me.
You're totally fine.
Yes.
If people need to take their time, it's not a big deal at all.
Yeah, no.
Yeah.
Thank you. Okay.
I felt like at the beginning, some of, the people that were in our group were like, hurry up, hurry up. And I feel like us four are like, no, just take your time. Better.
Yeah, you guys have had to wait on me a lot, so.
And me too. Like on everything.
And me too.
It's
We
okay.
all have our turns.
Did you say 0.728?
Yes.
Okay. Ooh, thank you.
Yay.
Yay.
Right.
Okay.
Okay, so question 10 is what is the direction and strength between the score and confidence? So is that still the same as we're just looking for the direction? And if,
Yeah.
like we did before?
In this case, it's positive.
Mm-hmm.
Yeah, it's positive. Do you guys, I'm trying to look for where it says. So at what point does it become weak?
When it is close to 0.
When it what?
Yeah, I was looking
When
here.
it's close to 0.
Okay, so we're still strong then.
Okay.
Okay. Yay, okay, good.
But does it matter, guys, because in the other question, it said, what is the direction and strength between weight, W-A-I-T, and duration? And then,
that's what we were measuring in that previous, in the old.
oh, I got it. Okay.
Yeah, we were measuring duration. In this one, we're measuring score and confidence.
Well, I thought we were doing two different things. Okay, so positive and strong?
Yes.
Because it's kind
And
of
we got
close.
100%.
Yay! Only 10 questions. That's awesome.
That's amazing. I know. What an easy
Okay.
lesson.
That was good. Well, I don't know if it's easy, but
Okay. Easier compared to other lessons.
yes, that is true. Okay. So you guys, we're gonna do the next one. The number, what are we on? 22?
Yes.
Yeah.
Everyone game.
Is everyone game? Is that what you said? I am, I guess.
Yeah, I'm good to go.
I'm good to go too.
Mm-hmm. Yeah.
Okay, where is it? Let me open it.
This one's 15 questions.
Yeah.
Oh.
Well, it's all right.
Okay. We got this.
I'm almost there, guys. Okay, it's almost up. Want to read this time? Anyone, or do you want me to? Well, whoever would like to read.
I'll give you a break, Kathleen.
Oh, I know, it's so hard.
All right. The first two you do on your own. Okay, number 3. Given the linear regression equation y equals 2.0 plus 1.5x, what is the y-intercept? Round to 1 decimal. We got to use the math self-efficacy.
We gotta do what?
We have to use the Excel math self-efficacy. Up above.
Oh, I see.
I'm not good at saying that.
Oh, I don't know.
That's a hard word.
Efficacy.
That is a hard word.
Efficacy, but it was the one we just did, so
Yeah.
it should already still be in your Excel, which is awesome.
Oh, okay, cool.
We made it easy.
Amen.
Okay. So we're looking for
Y.
Y. Well, on here it says the value of B. I'm probably looking at the total wrong thing.
So we need to find first x, right? What is it, x?
Yeah, we need to find x first to be able to find y.
Mm-hmm.
What? No. I wasn't responding. I wasn't responding to you guys. I was responding to my thing that popped up on my computer.
What?
No, I'm responding to you guys. What?
Funny. So, just right after you finished saying that, I was like, what? I swear, it wasn't you. It was my computer.
Okay, so I need help. I need help. Who can help me? I'm confused.
So I'm trying to see if they did it with the Excel spreadsheet.
Well, that's what I was wondering. Where M is the slope and B is y. Where goes that?
Times the 60. Okay.
Of a linear equation. Given the linear regression.
So the exponent variable equals the independent variable, which equals the x variable. So in our Excel spreadsheet, the explanatory variable x is in that column. Okay. So then that.
When I was reading, I could be totally wrong, which I probably am. But it says the y-intercept.
It's one.
The value.
Oh, sorry. Go ahead.
Oh, I was just going to say on here in the book, it says the value of BO, which would be 2.0, is the y-intercept, and B1 is the slope.
Yeah.
Is that right?
So it's 1.296 for number 3.
Now, how'd you find that out?
The y-intercept?
Yeah, the y-intercept, BO. If you look in the model.
Yeah, I see it. The 1.296 and then the 0.042.
That's the slope.
So we take that equation of, sorry, I'm getting there.
Oh, I see the B and the O.
Y equals BO plus B1X.
Mm-hmm. B1X, or just B1, technically.
And that's how we find X, correct?
Well, all it's just asking on 3 and 4 is what is the y-intercept, and you just go to the cell and you look up that, and then the next one's asking what's the slope, and then you just look at the one.
Okay. So it's 1 point.
So they're really easy. You don't have to do math for that.
Oh, good.
Why was I thinking of something else? Okay.
Oh, yeah,
that's why I was thinking. Yeah. Okay.
I'm glad I did the individual prep, because if I didn't do that, I think I would have been doing some math by now.
But why they are giving us the y equals 2.0 plus 1.5? I think they are referring to this equation, right? Like maybe what is the y-intercept? It's going to be 2.0.
Yes, but the y-intercept is on the spreadsheet, Raquel. It tells you what it is under model and under B.
So it's different.
Yeah. Okay.
But why is it different?
296. What, Kathleen?
Why is it different from the 2.0?
It's different, right?
I know, that's why I was confused, but I don't know.
So maybe we're not supposed to use the Excel until they tell us.
I think, yeah.
I think. Yeah, because in question six, they are asking us for the math self-efficacy.
Oh, you're right. You're right. Okay, I probably just jumped too fast. Sorry about that. You're right.
No, you're fine.
So what?
That's what,
What,
okay.
guys?
I was confused.
So I think it's 2.0.
Oh, for the first one?
Yeah,
For
in the linear
three?
regression equation. Okay, what is the y-intercept? Yeah, 2.0.
Yep, just that equation that's in front of you. Sorry, guys. I thought
That's okay.
we had to jump to Excel to get all that.
Yeah, I was confused because they asked.
Well, I'm the one who said to use it, yeah, so it's my fault.
Okay, so it's the first one, and then
Your slope is
the
1.
linear.
Yeah, 1.5.
Okay,
Hmm.
all right. I'm good.
Question number 5. So given the linear regression equation, y equals negative 3.0 plus 0.25x, what is the predicted value of y when x equals 16?
So we just put it in and do the math?
Mm-hmm.
The answer is going to be 1.
Wait, you're way ahead of me.
Cut it
You're so
out.
fast.
Cut it out.
You guys are so fast.
It's one. You're fast.
Kathleen's like, stop.
Now wait, I totally did not get that, you guys.
Remember the negative in there, Kathleen, in the equation.
I
Yeah.
hate that. So it's a positive.
It's a positive
It's a
one.
positive 1.
Mm-hmm.
It's a positive 1.
Yeah.
The negative 3.0.
0.25 times 16 equals 4. 4 minus 3.0
Oh!
is 1.
I got to do that first.
Negative 3.0 plus 4, which is still a positive 1.
Yep,
Mm-hmm.
exactly.
Okay, I got it. Thanks, guys. All right. I gotcha. I'm good.
Ready?
Yep.
Okay, so
Yep.
the next 7 questions, use the math self-efficacy Excel file. Be sure to use the confidence data for the explanatory variable and score data as the response variable. Did we do that?
Confidence data. Where is that? Ooh, does that mean we have to flip them
Yes.
around? We do?
Mm-hmm.
So the confidence, for the explanatory.
So the confidence is the explanatory and the score is the response.
So we have to flip them around,
Yes.
right? Oh, geez. Okay.
I know.
That is tricky.
I know.
Yeah.
Well, one of them that I was doing, one of the practice things, that's what happened is I didn't flip it. And so, yeah, it was messed up.
Okay. Okay, so for number 6, it says, make the scatter plot and then of the data. Of the 3 data shapes introduced in the reading, which shape best describes this data? Hot dog shape, hamburger, or banana shape?
Well, I'm not there yet.
Okay.
Are you guys there?
I'm
Are
not
you guys? Okay.
I'm
I'm
with,
fast
I'm with you. It's okay.
because I'm old, I guess.
No.
We are waiting for you, Kathleen. No worries.
You guys are always waiting for me.
You are fine.
That's okay, now wait a minute. So the 4.34 goes in the first one.
Correct.
Yes.
And then the 50
Okay.
in the second.
All right, wait a minute. I'm getting there. Okay, I gotta clear this. Clear? Okay. And then the 50. Well, why do they do that? That's just confusing. Shouldn't be that hard. Copy. I'm almost there. Okay.
It kind of looks banana shaped.
It's a hot dog.
It's a hot dog shape, yeah.
I don't know. It's it is kind of weird though. It's not real together.
Like in the reading, if you look, they have it. So they have hot dog, hamburger, and banana, and it looks like the hot dog.
I think that's so funny that they name them after this.
I know, right?
Yeah.
I was totally laughing when they did the hot dog and the hamburger and the banana.
Okay, just so we have the right, just so I copy and paste it right. So the 50 at the top of is supposed to be in the y variable, and the 4.34 is supposed to be in the x, right?
Yes.
Okay, just making sure.
Yeah.
Okay. So what is the next question? What are we on?
Number 7. So based on
Number
the
7.
base of your scatter plot you produced in the last question, what can you say about the appropriateness of using simple linear regression to model these data? Simple linear regression is appropriate for these data. If simple linear regression is used for these data, the results will not be reliable. Simple linear regression is not appropriate for these data. I think it's the first one.
I think it's appropriate.
Well,
so for a hamburger, we say that linear regression is not appropriate. For a banana, we say linear regression is not appropriate. And for hot dog, we say conduct regression analysis to determine if there is a significant linear relationship.
oh, I see that.
Mm-hmm.
I found it. Okay.
Wow.
So,
Right.
So I think it's the first one, but you guys, let me know what you guys think.
If it's not appropriate.
I think it's the first one too.
The first one too.
Mm-hmm.
Yeah, I agree. I think it's the first one.
Because it's appropriate because it's the hot dog shape.
Yeah, I agree.
Okay. We'll try it.
Mm-hmm.
How many observations are in the data?
Mm. 160? Is that? Is it the number of things? Is that what it's asking?
I think so.
How many observations are in the data?
An observation.
Yeah, I don't know how to get this one.
Where did you get 160, Kathleen?
Where the X in Excel, it says X is 160, and that's how many numbers, or how many, oh, I don't know, because it says 142 here at the bottom.
Yeah.
Do you guys see the X equals 160 on your Excel?
No.
No.
What does your X say? Huh?
Which cell and column is that you see that in?
It's just under confidence. You see where it says t-test for linear regression? It's G, whatever that is, and right across from 18.
Mine says 6 in that spot.
Says what?
Like under the X, mine says 6.
6?
Yeah, mine too.
Yeah, mine.
Well, then I'm really messed up then.
Yeah, mine says 6.
Well, how come I'm so messed up?
Oh, it's okay.
I don't know.
Okay. So
Kathleen-
yours, what?
Kathleen, I want you to try and clear off your thing. Oh, I want you to try and clear off your Excel, because maybe, do you think you copied over it?
I thought I cleared everything out. I don't know. What does yours go to at the bottom? What does yours say, you guys? Under X, the variable X and variable Y. At the very bottom.
3.77 and 70.
That's
Yeah.
what I have.
So it's not that.
Hmm.
I don't know.
What is your R?
0.728.
Yeah, that's what I got. I don't know why my X is 160.
You want to try and clear it one more time and then do it again?
No, because it will take me forever to do that.
You're like, I refuse.
What is the next question? Let me look. How many observations?
How many observations are in the data?
Okay. I'm not sure what that means. Do you guys know? Observations. I thought that was just how many numbers we have, but I don't know.
I don't remember the reading or the video.
Mhm.
Yeah, I went through the video. I don't see it.
You don't see it listed around there?
No.
I don't.
Hold
I
on.
can't find it either. How many observations? Observe. Oh, golly.
Nobody's posted the question. Okay.
I'm looking through the book part and I don't
Yeah.
see it. Yeah. Haven't we talked about, I mean, observations are just how many numbers that we have or how many sets? I'm not positive, but I don't know what else it would be.
I think it's how many observations. I think it's the number of. Let's try that. I mean, if we get it wrong, then we get it wrong. And we can figure it out after that.
But you guys got a different number than I did.
Well, if you highlight how many data points there are, just
Uh-huh.
for X, it's 139.
Now, how did you do that?
I just took my cursor and started with the very first one, 4.34, and dragged it all the way down to the bottom of the data set. So 3.77. And it tells you that there's 139 items. Does that make sense?
No, I don't even see that. I'm sorry.
So just in your cell, A4.
Okay, wait a minute. Let me get up there. Yes.
So
Yes.
if you A4 and you drag it down, highlighting all of the data in the cell.
Both columns
No,
or just in that
one.
cell?
They both have the
Okay.
same number of data points.
Yes.
You stop at 3.77, you have 139.
Oh, I see that. Okay.
So would
Okay.
you agree to use that number, or do you want to keep trying for something different?
I
Raquel,
would say that 'cause I don't know.
what do you think?
I'm not sure. I would try what you're saying. It
Try
makes sense. If not, we can just spend more time looking later.
Well, and we can always
Okay.
email her and ask her for some assistance if we get it wrong and we just can't figure it out too, and submit it again
Okay.
next time.
Yeah.
That sounds good.
Okay. Okay, we're gonna try and error. Okay. The question number 9 is, what is the y-intercept? I have 18.690.
Yep.
Yeah.
Okay.
Okay. And then the slope,
Yep. What's the slope?
12.695.
Yep.
Yeah.
Okay.
11. Are you guys ready?
Mm-hmm.
Okay.
Yeah.
What is the predicted value of y when x equals 4?
Let's see.
I got 69.47.
What did you get?
69.47.
Is it because you put in, did you plug it in, the linear regression equation?
I didn't plug it in. I just did the math.
And what did you get, Mackenzie?
69.47.
That's what I got.
What?
Because it's y hat equals the y-intercept, which is 18.690, plus the slope, which is 12.695 times x, which is 4.
Okay, well, I went back to this other one. I'm totally confused. I went back to question 5 and put it in there. So we
Oh, in question 5. Oh, yeah.
so we use, let me look.
I mean, it's kind of good to use as an example just to see how your equation is set up, but you just have to remember to plug those back in.
Did you get
Okay.
69.47?
Uh-huh.
Okay, I did it right then. Yay, I did it right.
Yeah, so Kathleen, it's going to be 4 times 12.695.
Yeah, I got the right one now. Let me see.
Okay.
695 equals 0.78 plus 69.47.
Yep.
Okay. I got it.
Woohoo!
All right.
Yay for me.
12. The confidence data resulted from students evaluating their confidence for each question on a scale of 1 to 6. What is the maximum predicted value of y for these values of x? Hint, because there is a positive correlation, we can use the largest x value to find the largest predicted value of y.
Oh.
Uh-oh.
Uh-oh.
So this is where we grab
For these values of x. Let me see. I have no idea.
So is it, okay, so the predicted largest value of x is 94.859. So then the prediction interval for y is between 72.273 and 117.445. So do we plug in that or use that 117.445?
Where are you looking?
Yeah, where are you?
So if you go on your Excel sheet
Yeah.
and if you look under H18, is predicted for X is 94.859.
Yeah, where it says confidence and prediction intervals for regression response.
Yeah.
Yeah, my numbers are screwed up down there though. Because that's something messed up in mine, but
If you look at M18
that's okay.
and N18, that's your prediction interval for Y. You see that?
Yeah.
So the 94?
Huh?
Or-
The 94, I believe, is for X. But if you go over to M and N, sorry, can't talk today.
The prediction interval.
For Y is 72.273 and 117.445.
Yeah.
Okay, yeah.
So what does that mean?
Highest one as 117.445.
Mm-hmm.
Is that what I'm reading?
Yeah.
Would you guys understand
So-
that too?
Let me see.
Just keep cutting out a little bit, but it's okay.
Oh, what is the maximum predicted value for Y?
Yeah.
Oh, yeah, that makes sense. That's probably right.
I think it's the 117.
Okay. I'll put that in.
I think that's right.
Yeah.
0.445. That one?
Yeah.
Yeah.
Okay. Mm. Always place the number of managed schools.
How many? Planetary is X. You guys ready for the next question?
Yeah, I am.
Okay. How many explanatory independent variables are present in simple linear regression? More than 2, 1, or 2?
2, isn't it?
So it's the independent variable, which is the X. Mine says 6.
How many independent? Or are we supposed to look in Excel?
Yeah, that's where I'm looking.
So it should be more than 2.
Yeah.
Where do you see that?
It's where it's in G18 under the X. Mine says 6.
Oh, under the X?
Yeah.
Oh, that's where my X is messed up. Okay.
Yeah.
Is that where yours says 160, Kathleen?
Yes, yes.
Oh.
Okay.
How did you get 150?
I don't know how I got that, but I did. So
Oh, it's okay.
Okay.
Mm,
So are we saying more than 2?
I guess so.
Okay.
that's independent.
So how many response dependent variables are present in simple linear regression? So the
Simple linear regression.
Are you subtracting those?
I don't think I'm doing it right, guys.
Yeah. It's probably maybe like a role or
I
concept.
don't know. Some of these are so confusing. I'm not sure.
It is confusing.
Explanatory. Let's see.
So we're looking for dependent or present.
I gotta look at the video.
Yeah.
Let's see. Independent and dependent.
Okay, so it just says the independent variable is x and the dependent variable is y.
Yeah.
And then it states the independent is also the explanatory, so the first column. And the dependent variable is the response variable, the second column.
Oh, so they just want us to count those?
No, I think it's something different than that.
Let's see.
Dependent response y is variable, which is affected by what happens. That's probably what you just read. Is that what you just read?
Hmm.
The independent or explanatory variable x is the variable which is not affected. The dependent or response y. Hmm. Hmm.
I don't know. I'm kind of at a loss.
Well, since it's asking for more than 2, 1, or 2, well, you've got an x and a y, right?
I would say they're both more than 2.
Hmm. I'm really not sure. I guess.
Sorry, go ahead.
No, you go ahead. You go ahead.
You don't think it's maybe question 11, that answer?
Which one's that one?
69.47.
Well, if it is, then it's still more than 2. So, yeah.
Should we try that?
We can try it.
I mean, we can try. If we get it
Yeah.
wrong, then I can ask her for some assistance
Okay.
and CC all you guys, and then we can see what happens from there.
Yeah.
Okay.
All right, number 15. A company in South Dakota manufactures hard hats used in the mining industry. They record measurements on all the hats they produce for quality control and planning purposes. The measurements they collect include hat size, circumference of the hat, and lengths of the major and minor axes, meaning the company wants to predict the size of the hat given their circumference. What is the response variable? We want to measure. So the response variable is the circumference.
Because it is a variable being predicted.
So yes, the size of the hat is the x variable, and the y is the circumference, if I'm reading that correctly.
Measurements as a hat size, circumference, and lengths.
The response variable is the one that is going to be affected by something.
So the hat size.
Yeah, it would be the hat size of the hat, wouldn't it?
Yes, because okay, so sorry, they want to include hat size, circumference of the hat. So the hat size is going to be determined by the circumference. No. Collect and include hat
Because
size.
it is being used to predict circumference.
So they want to know, they want to predict the size of the hat given the circumference. I still think it's size of hat. What do you guys think?
I think it is too, but which one? The first one?
Yes.
Mhm.
I think so.
So wait.
What do you think, Raquel?
I'm looking just for, it says, in regression analysis, the variable that is being predicted is the dependent variable. So let me just,
So the size of the hat is being predicted.
and the dependent,
The circumference.
what is the response variable? Yeah, you're right. I think, yeah, it's the first one, the size of hat, because it is the variable being predicted. Because the dependent variable is the response variable.
Mhm.
Mm-hmm.
That is so confusing. I'm
Yeah.
just saying. Okay.
Mm-hmm.
I
who
submitted.
wants- You did?
Yeah. Got a 70.
Oh!
Wow.
Okay.
What ones did we miss?
So we missed number 9, number 11, 12, 13, and 14.
Oh my gosh.
9.
So I knew we were doing something not quite right on 13 and 14. So I wasn't surprised with those two.
Mm-hmm. So did you say 9, 10?
So number 9, what is the y-intercept? Number 11, what is the predicted value of y when x is 4? And number 12, the confidence data resulted from students evaluating their confidence for each question on a scale of 1 to 6. What is the minimum predicted? Oh, the minimum. We did that. Oh, wait, no. What is the maximum predicted value of y? And then how many independent variables and how many? Oh, you know what, guys? I think I just.
Wouldn't it just be one for
The independent and the, yeah.
for 13 and 14? That's what I think.
Yeah, you're right. That's what it is. It's 1.
Because there's just one of each, right? That you're taking.
Oh,
Yeah.
that's right. Oh my gosh. No, but I do remember that from the video now, so that makes sense.
Yeah, otherwise it's gonna be multiple,
Okay.
multiple linear. Mm-hmm.
Hey, our observations in the data was correct.
I know.
Oh, good. Yes. Okay. So number 9, y-intercept.
9.
How is that not 18.690? I don't get it.
Let me look. So what is it asking? The y-intercept. What is the y-intercept? Well, I'm looking in the book and it gives an example of the y-intercept. It's talking about the crocodiles. And it has the negative, I mean, it gives the first number. Well, on here, it's negative 18.274.
Mm-hmm.
And that says the y-intercept is negative 18.274.
Yeah, but it's still the same like BO, B1 in the Excel.
Right, and the BO is the 18.690.
It sounds really. You guys are talking about BL here.
Yeah.
Oh no.
Did we miss the slope one too? Did we miss 10 too?
No, we got 10 right.
Well, how could that be?
Yeah, I think that's a typo in there.
I think so too. Maybe it's a mistake
Yeah, I think
on the quiz.
yeah.
Because if the slope is correct and we all got the same for the y-intercept,
Yeah.
you would think it would be correct.
So did you get 18.690, right?
Yep.
Yeah, that's what I got.
But I got 2.
And you're just supposed to round to 3 decimal places, so I don't know.
That's kind of weird.
So what are the ones you got wrong? It's 9.
It's 9, 11, 12, 13, 14. 13 and 14, I think we think is 1 and 1 because it's one variable being measured for one variable.
Yeah.
So I think, yeah, you guys change that one and let's see if it's correct.
Well, I think 9 is still the same, but I don't know.
Hold on, I'm going to check out.
Should we figure out question 11? What is the predictive value of y when x is 4? Well, we probably missed that if we don't have the correct y-intercept.
Yeah, something's interesting about that. I would agree.
So that's why we missed it if we don't have the correct y-intercept.
Yeah.
Oh.
But the input of the data just like it was supposed to be.
Well, it doesn't tell me in that one.
Okay, I'm gonna plug it in. See if I can't get different. Maybe their numbers changed from the last quiz to this quiz.
I don't know.
We just left it in. I'm just gonna check it to make sure nothing changed.
The y-intercept with the symbol BO and the slope with the symbol B1.
Still shows us 18.690.
What?
Said it still shows as 18.690.
Um,
Not.
well, maybe we should ask Dr. Withers or something. I don't know.
I'm going to send her the email with the questions.
Okay. Does she answer right away or?
It usually, like, it just depends if she's online or not.
Okay.
Okay.
And then we still missed question. Wow.
What?
9, 11, and 12. 13,
We
14.
can use the largest X value to find the largest predicted value of Y.
I don't know that one. I'm going to have to ask her. Can you help me on that one? I'm lost. I thought it was that, but it's not. We could probably. I'll ask her on that one too.
Yeah, that sounds good because I don't know.
Okay. I'm going to email her. You could probably stop the recording, Raquel.
Okay.
I will be right back. I have to go use the restroom.
No, Mackenzie, it's not allowed.